Hi folks, it's Mr. Moodlage here with another video. In today's lesson, we're going to look at one of the most important skills in this unit, which is taking a graph of a sinusoidal function and writing an equation for it. So instead of being given an equation and drawing the graph, we're actually going backwards. So we're looking at the curve first, and then from the graph, we're trying to figure out the equation. Okay, so by the end of this lesson, I want you to be able to look at a sine or cosine graph and identify four important things, which are the amplitude, the midline, which we also refer to as the equation of the axis, or EOA for short, the period, and also this notion of phase shift. Okay, so once we have those four pieces, the equation becomes much easier to write. And the general form that we're going to use is like this. Y is equal to A sine K theta minus H plus D. Or we can also write it like this. Y equals A cosine K theta minus H plus D. And that's in degrees there. Notice that, sometimes instead of theta, we'll see x, but the idea is exactly the same. Okay. All right. So before we jump into the graphs, let's review what each of the letters, what each of the letters, what each letter does. Okay. So A, K, H, and D. So the A value controls the amplitude, and the amplitude tells us how far the graph goes above and below the midline. So if this is for this graph, if this is my midline, the amplitude tells me how much above and below it goes. And the way that we calculate our amplitude precisely is using this equation right here. So maximum minus minimum divide by 2. The D, and that's how you find the amplitude. The D value is also called the equation of the axis, or the midline, and it's the horizontal line that cuts the graph right through the middle. So like in this case, like that. To find it, we use this equation. Midline is equal to max plus min divided by 2. So like finding the average. Moving on. So that's in terms of like the vertical stuff, the amplitude and the midline. Now we get into the horizontal stuff, like the K value and H. So in order to find K, we need to realize that the K value controls the period. And since we're working in degrees here, we use period is equal to 360 divided by K. Or rearranged, K is equal to 360 divided by period. All right. Last but not least, finally, here we have H, which is the horizontal shift or phase shift. This tells us whether like the sine, or where the sine or cosine curve starts. So here's the big idea. There's usually more than one correct equation for the same graph. So a graph can often be written as a sine equation or a cosine equation. And you can also use a reflected sine or reflected cosine. As long as the equation produces the same graph, it's correct. Okay. So here's a helpful way to decide whether to use a sine or a cosine. Okay, so if you want to use sine, look for a point where the graph crosses the midline. So in this case, the midline is here and goes up, because that's what the shape of a sine curve is like. A negative sine starts at the midline and goes down. So that would be like a reflected sine. For cosine, look for a maximum. A maximum or a minimum for cosine. But for a positive cosine, starts at a maximum and then, it has to go down. For a negative cosine, or reflected cosine, it starts at a minimum and goes up. So really, in a nutshell, when I'm looking at a graph, I'm asking myself, do I see a nice midline crossing, like in the case here? then sine might be easy. Or do I see a clear max or min? If that's the case, then cosine might be easier. Okay. All right. So let's start with the first graph here. I know it's been completed for us, but let's just walk through what's going on here. So I can see here clearly that the lowest point is 4 and the highest point is 8. So from that, I can find the midline for the equation of the axis, the EOA. So that's going to be 8 plus 4 divided by 2. So as we've done here, and I get my d value of 6. So the equation of the axis is y equals 6. Now I can go ahead and find the amplitude by taking max minus min divided by 2. And so 8 minus 4 divided by 2 is 2. You can also see that from here, from 6 to 8 is 2. From 6 to 4 is also 2. And for amplitude, we take the positive value. Okay, so it's like a magnitude. So amplitude is 2. So far, based off of these two, we have something like this, right? Just based off of those two pieces of information, we have this equation right here. So y is equal to 2 sine k x minus h plus 6, right? Or y equals 2 sine k x minus, or sorry, cosine k x minus h plus 6. So that's what we have so far, right, from here. Now we need the period. So on the graph, we could see one of the minimum is at an x value of negative 180. We could see another minimum here at 540. So the period is going to be 540 minus negative 180, okay, which is 720 degrees. So now we could use this equation right here to find k. Period is equal to 360 divided by k. Rearranged, right? K is equal to 360 divided by period. And since we know our period is 720, well, 360 divided by 720 turns out to be a half. So we now know our k value here is equal to a half. So now we know A, we have A, we know D, and we know K as well. So now we have to choose, now we have to look at, well, we have to decide, am I going to use sine or cosine, right? And that's going to help us figure out what the h value is. So I look at x equals 0 here, and I notice the graph actually crosses the midline y equals 6 and is going up. So this matches a positive sine curve. So a nice sine equation would be just 2 sine k is half theta plus 6. Okay. And that's what a positive sine and a sine equation would look like. So let's also try to write down the cosine equation here. So for the cosine, we want to start at a maximum. So there's a maximum right there. Notice here on the x-axis, there's 225 degrees is broken up into a span of 1, 2, 3, 4, 5. So 225 divided by 5 is equal to 45. That's how I figured out each of these increments here. Okay, but the idea here is that you could see it's, the maximum happens at 180. So a positive cosine curve starts at a maximum. So we would write this as y equals 2 cos half, and then theta minus 180 degrees plus 6, as we've written here. And it just means that we're taking like a regular cosine and we're shifting it 180 degrees to the right. And that's what we have. When we this way it matches this. This is like the transformed function, right? So both equations here and here are correct. If you graph them on Desmos, I know they look different, but they create the exact same graph. Okay, so that was a good warm-up to begin with. Okay, so let's take a look at our second example here. And let's actually do this one from the very beginning, from scratch. Okay, so let's find the highest and lowest values. So here I'm always looking at my axes, looking what the scale is. So here it's 5, so I know this is 1, 2, 3, 4. And here it's 60, so this is going to be 15, 30, 45, and so on, right? So maybe I'll mark those, at least the first one so I could see. 30, 45. So that'll remind me, and this is going up by 1, 2, 3, 4, and so on. So I could see here, let's find the highest and lowest values. The maximum is about at 7, and the minimum is about, well, it's at 1. So the midline, I could say the D value, D is equal to 7 plus 1 divided by 2, which is going to be equal to 4. All right, so I've found the equation of the EOA, equation of the axis. And then I can go ahead and find the amplitude. So A is going to equal 7 max minus min divided by 2. So that's going to be 6 divided by 2, which is 3. All right, good. I found my second piece there. So now let's find the period. So I could see here the graph has a minimum. So what is that x value there? That's going to be negative 75, negative 90, and then another 15 over, so negative 105 degrees. And here it's 60 and then 75, right? So I could see the graph has a minimum at about, well, at negative 105, and then the next minimum right here is at 75. So that span right there is going to be 75 degrees minus negative 105, right? That's how I could figure out that total span. Essentially from 105 to 0 is 105, negative 105 to 0 is 105, plus that 75 degrees. So this is going to equal 180 degrees, right? If you do that, the math there. So now to find K, well, K is equal to 360 degrees divided by period. Okay, and here it's just 360 divided by 180, which is going to equal 2. So my K here is 2. Essentially, this graph has been compressed by a factor of 2. Remember, the bigger the K value, the more compressed it gets. So imagine you're taking like 360, which was the normal period, and now you've shrunk it down to 180. So you could fit 2 of these in a regular 360. Okay, so this is one cycle, is 180 degrees. Okay, so now we have D, A, and K. So now let's write our two equations here. So let's say we wanted to make it a sine equation. So let's write a sine equation first. So I'll say sine equation for short. Okay, so if we wanted to write a sine equation, then we need to realize that a positive, and let me actually label this here as well. So 4 here, that's my midline or equation of the axis. I need to notice here that, a positive sine starts on the midline and goes up. So on this graph, that occurs like right there at negative 60. So that happens at an x value of negative 60. So I can conclude by writing, well, the equation would have to be y equals, here I can literally say it right here, but, the h value would have to be like negative 60, right? Negative 60 degrees, because that's where like it would have to shift 60 degrees. Well, okay, think of it this way. I want you to think of it this way. The x value would have to be negative 60. So that's when like the actual sine curve, like the positive sign is occurring. Okay. So what happens is now when you sub this into the equation, so we have y is equal to a, which is 3, because it's positive, so it's going up. And then we got sine k, which is 2. And then we have theta, and it's theta minus h, right? But then 2 negatives gives a positive, so it becomes theta plus 60 degrees. And then we got plus d plus 4. So this would be our actual sine equation. And this is the h value. What's important to note here is that this is, you know, theta plus 60 degrees. This means, all it means is that the graph, the normal sine graph, starting like, let's say, starting something like here, has been shifted 60 degrees to the left. That's all that means. And yeah, so the h value is negative 60. Okay. So let's go ahead and also write the cosine equation here. So a positive cosine starts at a maximum. So like right over here. And we could see here that, well, the h value would have to be negative 15 degrees. So I'll write here for the cosine equation, the h value would have to be negative 15 degrees. Okay. And then, therefore, the the actual function would have to be y equals 3 sine 2, and then theta, and then, it's minus h, so then it's going to be plus 15 degrees plus 4. And that's how you'd get the, and this would, sorry, not be sine, this would be cosine, cos 2. So that would be the cosine equation right there. It starts at a maximum. This happens at negative 15 degrees. So 15 degrees shifted to the left, and you'd have your cosine graph. So both equations are valid, is the idea here. So there's 1 and there's 2. Okay, that's how you do it. Honestly, it doesn't take a lot, but it's just, those are the main steps. All right, let's keep going. So let's take a look at this example right here. This one looks like it's we have a negative midline. That's okay. So we're looking at a graph where the curve is mostly below the x-axis. So again, it's okay. Let's figure out our maximum. And here the scale looks like it's going up in increments of 0.5. So that's like 1, and then negative 1.5. It's negative 1. So it looks like our maximum is at negative 1, and our minimum is at negative 7, right? So the midline, so we could calculate the d value here. So d is equal to max plus min, so negative 1 plus negative 7 divided by 2. And that's going to be negative 8 divided by 2, so negative 4. So right over here, that's my midline. Y equals 4. So I'll box that. And then I'll find my amplitude A. That's going to be max. So that's going to be negative 1 minus min. So minus negative 7 divided by 2. So that's going to be positive 7 minus 1. So 6 divided by 2, which is 3. And that makes sense, right? From negative 4 to negative 1 is 3, right? So amplitude is 3. That's good. Moving on, we need to find the period. So let's find out, when does this minimum occur right here. Let's look at the x-axis. It looks like these gaps of, well, there's 1, 2, 3, 4. So 4 spanning 20. So 20 divided by 4 is 5. So each of these is 5. So that's going to be negative 5, negative 10, negative 15. You get the idea. So it occurs at negative 15, right? So that's at negative 15. And then this minimum again occurs at 40, right? So from 40 to negative 15, or negative 15 to 40, that period right there, so period is equal to 40 minus negative 15. So that's going to be 55. Sorry, did I say that right? Yeah, no, that's good. 20. Oh, I think I made a mistake. Sorry. That's not 40. This is 45. I thought that was 40. Sorry. 45 here. And so from 45 to negative 15, that's going to be 60. Yeah. Okay. So 60 degrees is the period. Yeah, because that would be 40. This is 45. It's going up by 5s. Okay. Nice. So the period is 60 degrees. So now I can find the K value. So I can say that then K is equal to period divided by, sorry, or vice versa, 360 divided by my period. 360 divided by my period. Yeah, that's always what the K is. It's the K value is like, well, if the period is 360, then it's 1. If the period is like, 180, the K value is going to be 2. So whenever the period is smaller, the K value is bigger, right? So that's why it's divided by, that's why it's 360 divided by the period. So it's going to be this, and then so 360 divided by 60, that's my period. So that's going to be 6. Okay, so my K value is 6. And now, so we have the A value, we have the K value, and we have the D value here. So let's come up with our two equations, right? So the sine and the cosine. So if I want to come up with the sine equation, which it looks perfectly like sine would be the, the best choice here if I had to choose between one, because it crosses at, x equals 0. It crosses at the midline and it goes up, so it's like a positive sign. So I can say like the sine equation is going to be like y equals amplitude is 3, that's positive because going up, and then sine k value is 6, and I don't need any phase shift because it's starting there, so 6 theta plus, or sorry, minus 4. So that would be one valid equation there, okay, for sine. And if we want to do a cosine equation, right, so here the phase shift h is equal to 0. So h is equal to 0 degrees, right? I don't need a phase shift. If I want to do a positive cosine, well, then I would need to figure out what is that h value. So here h, that the x coordinate there is 5, 10, 15 degrees. So h is equal to 15 degrees, which means the equation would now be like this: y equals 3 cos, so I'm doing a cosine, and then I'd have 6 theta minus 15 degrees. So 15 degrees shifted to the right, the whole graph, minus 4. And that would be my cosine equation right there. Okay, so double checking this. Yeah, so that would be the cosine right there. Okay, nice. It's always good to, while you're doing these, to check with like, with Desmos or some tool, just to make sure that you're doing it on the right, you're doing it in the right way. Okay, so very good. So this would be the cosine equation right there. Put a box around that. Nice. So we're doing great here. We can move on. So here is one that I kind of did before. It's annotated. Find the midline, or the d value, max plus min divided by 2. Here the max is 9, the minimum is -1. So we could see the midline is 4. The amplitude, or the a value, that's going to be max minus min divided by 2. So amplitude 5. What's interesting about this one is, like, it's not intuitive to see the period here, right? So notice that the minimum occurs at -30, the maximum at 90, right? And what you need to know, this is only half a cycle, right? Because from a minimum to midline, that's a quarter. And then from a midline to a max, that's another quarter. So 2 quarters makes a half, right? So that's not a full cycle, that's half a cycle. So what you want to say is, if half the period spans from -30 to 90, which is 120, that's half a period. Well, then a period is going to be double that, right? Half. Like, if you double both sides, you get a full period. So that's going to be 240. So a full period is 240. So now we can calculate K, right? K is 360 divided by the period, so 360 divided by 240, 3 over 2. Right? So that's good. The sine, so now we can actually figure out, do we want to graph this as a sine or cosine? Well, if we want to use sine here, that shift right there is 30 degrees, so h is positive 30, which means that in the equation, I'd have to have written like this with the negative 30 there, so theta minus 30. And yeah, I have my A, K, and D values there. If I wanted to make it as a positive cosine, well, I'm looking at the maximum here. It's at a value of 90 degrees, so I shift, so H is positive 90, I shift it 90 degrees to the right, which means theta minus 90 degrees. Everything else stays the same, the A, K, and D values. Okay, so very good. Nice. Okay, so let's look at an example here where the amplitude is small, right? So now we have some graph where the numbers are smaller, but the process is exactly the same, honestly. So you're trying to figure out the minimum here. Well, it looks like the minimum is 2.5. The maximum is 3.5, right? And the scale is going up by units of 0.5 again, so that would be 3. The midline, so D is equal to max, so 3.5 plus minimum, divide by 2. That's going to be 4 plus 2, 6 divided by 2, so 3. That's going to equal 3. And then the amplitude, so I'll put a box around that. The amplitude A is going to be max minus minimum divided by 2, right? So 1 divided by 2 or 0.5. Some of these, honestly, we could see from the graph, but it's always good to, prove them mathematically like we are here. Next thing we're going to do is similar to before. We're going to try to figure out what the period is, but obviously it's not, we don't have a full cycle here. We have half a cycle. From max to minimum is like half a cycle. So I could say, okay, well, from negative 30 to 30, that's a span of 60 degrees. So I'd say 60 degrees is equal to, well, I'd say half a period is equal to 60 degrees. So I double both sides, so I get 1 period. 1 full cycle is equal to 120 degrees, right? So then I can figure out my K value. K is going to be 360 divided by my period. So 360 divided by 120, that's going to be 3. So K is equal to 3. So now I figure out, do I want to make this a sine or cosine? What's neat here is that, if I wanted to make this, let's say I wanted to make this a sine curve. So let's say I wanted to go with the sine first. If I wanted to make it a sine, I want to notice that the graph crosses the midline right here. So naturally across the midline. But however, notice that unlike the other graphs, this one's actually going down. So this is an example of a negative cosine. So it's actually going to look like, the amplitude is going to be 0.5, but it's going to be reflected now. So negative, because it's going down. So it's going to be negative 0.5 sine. I don't need a phase shift because it's starting there. So the K value would stay 3, no phase shift, so theta, and then plus 3, because that's the D value. So this would be my sine equation, and H value is equal to 0, right? So as a cosine, that would be like a negative sine, right? As a cosine, well, I'm looking for a maximum. I don't need to look for a minimum unless I wanted to make it like a negative cosine. For a positive cosine, look for a maximum. There's a maximum right there. It's happening at an H value. So H is equal to negative 30 degrees. So phase shift of 30 degrees to the left. So that would mean that Y is equal to 0.5. I keep the positive cosine, positive A value, so 0.5, and then cosine of 3, and then I'd have theta plus 30 degrees, right? Theta minus H, so theta plus 30 degrees, plus 3. Okay, so that would be a nice cosine equation right there. Okay, so we can see both sine and cosine works. Both are correct. All right, let's keep going with this. I hope you can see, like, through these examples that we're doing, I know this video is getting a little bit long, but through these examples, all these that we're doing, the same procedure, right? It's the same idea. So let's do one here. We have a long period and, it looks like a small amplitude. So a quicker example. So here, I'm just gonna, for the sake of time, I'm gonna like write down, if we were to do the calculation, you would find that the midline here is equal to -2. So I'll say D is equal to -2, right? You can see the max here is what's going up in increments of 0.5 again. So that's like -1.5. This is -2.5. If you add those up and then divide by 2, you'd get -2. So that's good. The max is about -1.5 and minimum's at -2.5. So you can also calculate the amplitude here, max minus min divided by 2 to be 0.5. You can also see that from here to here, it is 0.5. Okay, so that's good. The period. Okay, so let's figure that out. So here we have from a minimum to a maximum is a span of 360 degrees. So that's half a period. So a full period is going to equal, let's say P for period is going to equal 720, double of 360, right? So K is going to be 360 divided by 720, right? So that's going to be K equals a half. So when the K value is smaller than 1 but bigger, well, it's between 0 and 1, like a fraction, this is getting stretched horizontally. Okay, so the K value is a half. So as a sine equation, if I wanted to start at this midline here, I'd have to shift it by an H value of 180. So H is positive 180. So then I could say sine equation would look like this. Y equals A, which is 0.5. It's positive because it's moving up. So positive A value there, sine, and then my K value is a half. And then in the brackets, I'd have X minus 180 degrees because I'm shifting to the right, right? Normally sine would begin like here. I'm shifting that to the right by 180. So minus 180 and then minus 2 because that's the D value. So that'd be as a sine. As a cosine, I'd want to start here. So then I'd say cosine would look like this. The H value would be 360. Or actually what I could do is I could not even worry about translating it. I could just keep it there and just invert it, right? Negative cosine. So I could say y is equal to negative 0.5, right? Keep it with no translation horizontally, no phase shift. Keep it a cosine, right? Negative cosine, because now it's starting from the bottom and going up, so it's going to reflect as if it were going up. That's it. And then I'd have 1/2, just x or theta, so I'll just use x, it's okay, and then minus 2. So that could work equally as well. So this is another option because it's a reflected cosine, starting at the minimum, right? So the main idea here is that even when the graph looks very stretched out, we use the exact same process. Okay, so very good. And then let's look at one more example here. So last quick one. The maximum here is 6. The minimum is -2. So the D value is going to be 6 plus -2. So 4 divided by 2 is 2. Okay, the amplitude is going to be 6 minus -2. So that's going to be 8 divided by 2, which is 4. All right. Notice how quick these are now with practice. The period. So we're looking from -180 to 360. So 360 minus -180. So that's going to be 360 plus 180. That's 540. And that's a full period. So period is equal to 540 degrees. And so we would say that K is equal to 360 divided by the period. So that's period. So that's going to be 360 divided by 540. And so that's going to be 360 divided by 540 as a fraction. That is 2 over 3, 2/3. So that's my k value. All right, good. And we could figure out, do we want to use a cosine or sine? Well, remember the d value is 2 here. I think using a cosine would be very clean because we can start at a maximum. So like the closest maximum is right there. So then I could say, well, the h value here looks like negative 180 degrees. So I might say cosine. As a cosine, I'd have y equals, and starting at a maximum, so then I'd have the amplitude 4 cosine, the k value is 2/3, and then I'd have x, or theta, plus 180, because it's always theta minus or x minus h, so it's just the opposite there. And then I'd have my d value, which is plus 2. So that is as a cosine, right? Very clean, nice and easy. Will work, okay? A sine version could also be written by choosing the midline. So right here, or right here would be better because then it's like the midline going up. That's a positive sign. If you chose here, it'd be a negative reflected sign, right? So a negative sign. So here you just have to figure out what this value is, and then you can also do it that way. But for the sake of argument, I'll just do 1 here. It's okay. All right, just to wrap up here, to summarize, when you are finding an equation from a trig graph, don't just guess, follow the steps. First, find the midline, right? Using max plus min divide by 2. Then find the amplitude using max minus min divide by 2. Then find the period from your graph here, and you can calculate k using 360 divide by the period. And then lastly, choose a starting point, right? If it starts at the midline going up, like here, use positive sign. If it starts the midline and goes down, like here, use negative sign. If it starts at a maximum, so like here, so like let's say like something here, if it starts at a maximum, if we want it to start at a maximum, use a positive cosine. If we want it to start at a minimum, like here, use a negative cosine. All right. And remember, there could be more than one correct equation for the same graph. Okay, so here's the homework from the Nelson Functions 11 textbook. It's just one question here from page 392. So go ahead and give that a try. All right, thank you.